Okay, this is going to be a short. This is going to be a short presentation about two different shore types: the sandy shore and the rocky shore in the littoral, in the tidal zone. And this covers 6.7 here in the textbook, and it covers page 108 to 109 in the textbook. Again, this is just, me and a whiteboard. There are videos where you see all these animals in much more detail, but I'm just going to here try to describe some of the major implications of this chapter. When we talk about the littoral or the intertidal zone, we are talking about the coast. And we're especially talking about the coast, leading from, the highest tide, when the tide is at the highest to when the tide is at its lowest. And this is a very important zone for us humans. It's where many of the activities we have regarding the sea happens: surfing, going swimming, going fishing. And if you look at where some of the first people who lived in Denmark, where they got their food, it was from here, as hunting mussels, stuff like that, were very important to Stone Age people here in Denmark. So this intertidal zone is quite important to many human activities. It's also important for you as marine biology students because it is a place where you can easily go. It's quite hard to get to the abyssal plain, like really, really hard, but being able to go to the coast and see zonation on the rocky coast, almost anyone can do that. So it's also a very accessible point for doing marine science. So, in general, when we have the coast here, we talk about the shape of the shore. We talk about how much wave action come and affect it. We talk about the substrate, and we talk about the organisms who live here. And here I'm just going to outline the difference between two shore types that are like the typical shore types we'll see in Denmark: the rocky shore and the sandy shore. The rocky shore is, no surprise, a coast that is mainly made out of rocks of different sizes. When we have a rocky coast here, it is, of course, over time, it get affected by erosion. Over years, wave crashing into it will wear down the rocks and they will tumble about. But in general, it is a kind of stable environment, because if you have, these huge 300, 400, 500-pound boulders, they don't just move around like pebbles unless you have an extremely strong storm. So it's a quite stable environment for substrate. It also means the shape of the coast normally stays the same. Of course, it will change over time, especially if we have sedimentation, stuff like that. But it's quite stable. If you compare that to the sandy shore, well, the sandy shore is way more affected by wave action. If you've ever been to the coast, you just see the sand moving around. And you go to one coastline and you go there next year, and you can see how the sand dunes move due to wind and weather. You can see the sand keeps moving around all the time. So it is a less stable environment. It is much more affected by erosion and deposition. And it also means that the animals and plants who live at a rocky shore and live on a sandy shore, they have two very different challenges. So, living in the intertidal zone of a rocky shore, you have a stable substrate to attach yourself to. And many organisms we find here on the rocky shore do take advantage of that. If you ever seen a blue mussel, for example, or see barnacles, they attach themselves very strongly to the rock, which means that when a larvae settles and find a good place, it stays there for all its life cycle. The good thing is, of course, you have a stable place to settle. It also means that once you settle there, there's nothing you can do about the tide. So when you have a high tide, you're covered by water, it's nice. Then you have a low tide and there's no water, and you have to find ways to be able to survive that. And there are different methods. Many mussels, for example, can close their shell, just keep water on the inside. Barnacles can close the top. Other animals, such as crabs, for example, they can crawl in between the cracks in the rock at low tide. Sea stars can also move around. Further down, we also might find seaweed attaching itself to the rocks, and they can lay low when there's low tide. When it's high tide, they'll flow around and do photosynthesis. So animals adapted to living on a rocky coast, they need to be able to adapt to the fact that um, they need to be able to either move and hide, or they need to be able to attach themselves to the rocks. Also, when you attach like this, and if you have a storm coming in, you have to be very strongly attached because otherwise we'll get swept away. And we'll see that during the storm. Some will get swept away, but many animals are quite well adapted to living here on the rocky coast. As we get into later, on the rocky coast, we will see a very strong zonation, and we'll also see many different microhabitats, so we tend to have a high biodiversity. On the sandy shore, on the other hand, there is really nothing to attach yourself to. Attach yourself to a small pebble of sand, and you'll really don't have a home. So animals living here have to be able to move or to burrow. And we see many animals here on the sandy shore that they are very adapted to burrowing under the sand, which means that they make tunnels or they burrow themselves under the sand. It has some advantages. One is that when you then have a low tide and the top of the sand might get very dry, if you dig down a few centimeters, you still have moist sand, so you have water around you, so you avoid drying out and you can survive there. Another thing is, it is good when you have to hide for predators. If you've ever been, to a sandy shore, I hope you have, you'll see there's plenty of seabirds flying around all the time looking for food. So if you are a small worm or a crab or a mussel just sitting here on the sandy surface, you're a target, you're food, and any bird can sweep down and that's it. So being able to burrow is not only smart because you avoid drying out, you also avoid getting swept away by wave action, and you hide from predators. Other animals are mobile, such as fish who can swim around or crabs who move around with the tide. So they are mobile and they can move with the tide in and out, depending on how high the water is. If there's a lot of wave action, a sandy shore will look different than one with very little wave action. And if you have one with very little wave action, where it's very protected, we might end up getting muddy shores instead. And then we can have mud flats, where we have a different type of habitat. But we'll get into that later. It's important to remember that in the tidal zone here, it is very high in biodiversity, especially here on the rocky coast. And the substrate which you can attach yourself to, how you're affected by wave action, really is what makes it different from the rocky coast to the sandy shore here. This is just a very short review of it. I hope you take your time to also have a look at it in the book. But if there are any questions, please post them here below.